Yeah, from the day that I went to work for Atomics International, I started working at the SRE. At the time that I went to work on the SRE, it was not completed yet, and they put me in charge of a bunch of electricians, contract electricians, to make sure that the wiring was properly done for the instrumentation, uh, the wiring for all of the instruments that were there. And I would read the blueprints because they didn't have any experience reading blueprints, and I would show them how to hook up the wires and where to hook them up, and then I would check that the instrumentation was working by putting whatever sources we needed to use to check to see if the instrumentation were working properly. When the reactor actually achieved criticality, went critical for the first time, they moved me to one of the four shifts of the rotating shifts, and I would go in on that shift, whatever it was, and I was responsible for the instrumentation. I was to keep up, to make sure that all the instrumentation was operating properly. If one of the instruments went out, I would take it to the electronics shop and repair it or replace it and put it back in to and keep it going. That was my basic job. But in the interim of being there at night and things were slow, I would also be allowed to sit down and operate the reactor at various times. I have pictures of that I'm going to show you, of me at the operating console. Uh, as far as the radiation, I wore a film badge every day. I never had any high readings. I never come close to the minimums or the maximums that the NRC put out, and I was there through the entire operation. And in fact, I was there in '59 when the cladding failed and some of the little pieces of uranium fuel were let loose inside the reactor, but there was never any release or anything. We worked in the high bay the whole time. I'm going to show you pictures of us walking around in the high bay. And to show you what's really important is you're saying that there was fission products. Well, fission products, if you take it up in the body, and I'm somebody who's inside physically in the reactor room, and as soon as I went to UCLA, they put me in their total body counter. If there were any fission products in my body, that counter would have found them right away. And every 6 months, because we had a reactor on campus, they put all the people that worked in that reactor through the total body counter to make sure that we picked up no radioactive materials. And they'd see the cesium, they'd see anything that fission were. So there were no fission products got out of that reactor whatsoever.
Can you tell me anything about the structure, your memories of what it looked like, for example? Describe the building.
Well, it was a completely closed concrete building. The reactor vessel itself was stainless steel, very thick walled. It was all down in concrete vaults because of the radiation from the sodium. Once it went through the core of the reactor, it became quite radioactive. But that stayed all below ground in these concrete vaults. And we didn't have a lot of trouble with it. I mean, it was a very efficient reactor, and the current generation reactors that are water are about 30% efficient. That was 40% efficient back in 1957. I was there when they isolated the little town of Moorpark for a month, and we provided all their electricity, and it was the first city in the world that was ever provided with nuclear electricity. And we had no problems with it. I just, I can't, this was the world's second power reactor, and I thought we did a really good job. And you walked around all the time. Sure, you wore film badges, and we had monitors looking at the atmosphere, and there was no radioactive materials in it. And we had gaseous monitors, we had particulate monitors, we had health physicists. Frank Bold was the health physicist who generally worked with me. If I went down into any of the pits, he'd be there to make sure that the radiation in the pits was low enough that I could work down there for whatever amount of time that they allowed me to work down there. I melted some of the sodium the sodium would come in 55-gallon drums. We'd take a crane and swing it over and put heat pads around it and melt it to run down to the main tanks for use for reactor cooling. I've had lots of experience with sodium there. I probably did a little bit of everything that needed to be done on that facility, including operating it and doing the instrumentation. And I can show you some pictures. We did a transfer function. I don't know if you understand a transfer function, but we put an oscillator down the reactor core while the reactors, and we start the reactor up and it's running, and we put a sinusoidal wave pattern in for the power to come out that way. Then we looked at the output, compared the output to the input, and we measure something called the transfer function. It tells you a lot of theoretical things about the reactor that are very important. I was saying, in fact, they flew me back to Sanborn in Boston to understand some new instrumentation. Sanborn makes the EEG and EKG machines for hospitals, and we were adopting those machines to be used with nuclear power plants. So they flew me back there to learn about those machines to the point where we could adopt them to nuclear power. And I can show you some pictures of me working on those machines to do this transfer function. And what happened, and the cladding failed in a few of the columns. And I guess that the fuel, and I've seen them because we had a hot cell right there, but I don't think any of the fuel melted. I don't remember any of the fuel itself melting. I remember the cladding failed, that some of the elements went down, but it didn't affect the reactor in any way, shape, or form, because we pulled those out, put fuel rods back in there, and ran the reactor back up at power. If the reactor had any damage to it, we certainly couldn't have done that.